I'm here with video 20. This is my invention. As you can see, it's all kind of like torn apart and that. I just kind of want to go and explain some things. What I did was I kind of like hollowed this out a little bit so I had a little bit of clearance. And that this is for my coil to run inside here. Here's my coil. And it's going to fit in there. It's going to oscillate like so. You know, I got some parts he's been building. As you can see, this right here has adjustments on it. Comes up and down, back and forth. So that way I could adjust that coil in there. Okay, and I made some of these parts here. These are for the side things. This is for all of them. These are the pivot arms that I showed you on that first prototype. It kind of fits in there, and there's a bolt and stuff that goes inside there. It's kind of a neat part in that. And there's some more of these rings that fit over top of this. And I put some set screws. That's what's going to hold it in place. And that. So I've been busy working on it. Here's these other parts. And these are the magnets here that's going to go in it. A bunch of magnets here. This is what's going to make the energy, the power in that. These are 52 grade, highest magnet you can buy. It'll sandwich in between here, and it'll just give it enough weight for oscillation and stuff. These are some of the parts. And then these. Here I put these pins through here, and then that way when I put all this stuff together, all I got to do is push the rod through and everything's all in alignment. So all this is kind of built in like components. I kind of put it together, and that right now it's all apart so you can see what I've got. I've had some people talk about Lenz's law, and I just want to kind of go in on that. Here's Faraday's law right here, right hand rule of thumb, and that how it works and that. As you can see, this is in a physics book. Back right out a little bit. As you can see, as the coil and as it rotates, let me pull this out of here. As it rotates, as it goes through a field net, it creates this field right around it and creates a magnet. That's what basically Lenz's law is. Here I could read a little bit about Lenz's law out of this other physics books. I don't know if you probably can't read it, but I'll try to read it to you. It's probably a blur. It says the direction of the induced current that is always such that there's the own magnetic field opposes the changes in flux responsible for producing it. So in other words, as this magnet comes in and out of here, it creates a current flow when it comes through here. And it shows this direction. So basically, when this magnet goes through there, it's creating another magnet. And that's what's the problem with the generators of today. In that. This is, here's another thing. It says the same thing about how Lenz's law works and stuff. And I'll just kind of like move on with this over here. With this demonstration here. As you can see, these are 3 coils. This is a magnet. These are magnets here. Let me back out. See how far I back it up. This is a basic thing of a generator. This is like 3 coils or whatever. You could have whatever you want. It don't really matter. As this thing rotates, these are magnets, these are coils. It creates, as this comes past here and comes through these lines of flux, this turns into an electromagnet. As it comes past here, this turns into an electromagnet. As it comes past this one, it also turns into an electromagnet. So what it's going to do is, as it comes across here like this, it's going to try to pull it back. And that's where you got this thing. It keeps fighting. It's going to fight this between this. This is going to be energized, and it's going to keep doing that. It doesn't matter if this is on here or these coils are inside of here, and we'll say these little things here are magnets rotating around it, energizing it. Just for purpose sakes, I know these aren't magnets here, but as these rotate around, it doesn't matter if it turns around on the outside, the inside, whatever. You got the same thing that's going on here. It's going to rotate, it's going to energize, and it's going to pull on that as it comes past. And that's what Lenz's law is about. And that's basically my definition of insanity. Einstein's definition of sanity is doing the same thing over and over again and expecting a different result. And that's what basically how generators work. This one in particular is a coil with a magnet. As this moves through here, whoops, took off from me. As this magnet moves through here, this is going to turn into a magnet. But what's it going to do is, because it's oscillating, it's going to pull it back in instead of, see? That's what I'm trying to say. That's my theory behind it. As it oscillates, this coil keeps pulling it back in. And in that way, Lenz's law is eliminated. It's not trying to fight it, it's working with it. And I think it'll work much better in that. As you could see, well, we're going to do some demonstrations. Also, I got my transmission tore down, and that, as you can see, there's some counterweights inside of here. This is what helps it drive in that when it turns. It's kind of like one of those little toys that you could pull back and get the momentum going. You release it and it takes off. That's basically what it is. So on this invention, I don't think Lenz's law is going to be, it may affect it to some extent, but I don't think it's going to affect it like regular generators. That's the reason why a lot of these people and scientists have said over the years, if somebody could figure out some way of building an oscillating generator, you could have something that is far more efficient than anything out there. And these are lever arms and stuff that's in it. So this is way different what we got. You know, I mean, none of these other generators that you see have lever arms, or like this here that has a flywheel with magnets and stuff hitting that and causing the oscillation. Another thing I want to tell you is, if you go back to video 18, you could see where it sets up a sine wave. And this is James Clerk Maxwell. He's the one who talked about electromagnetic waves and stuff. This, if you go back to video 18 and kind of play it for a few seconds and stop it, play it for a few seconds, you'll see a wave where they're in different positions. And it's kind of like a wave effect, a sine wave, which he talks, this James Clerk Maxwell talked about, how everything runs on electromagnetic wave. And that's what I'm trying to tell you about. So go back to video 18 and play it a little bit and stop it. Play it a little bit and stop it. Play it a little bit and stop it. And you'll see what I mean by this sine wave. So, and that's about, I'm going to try and get this thing together, and I got some more parts to make, and that it's going to take a little bit of time, but I'm going to tell you, when it comes together, this is a whole different ball game. Everybody's been copying this guy right over here, Nikola Tesla. It's just got different versions of it. Doesn't matter if the magnets are on the outside or on the inside. And that's all they've been doing. So I'm going to kind of let you go, and I'll say goodbye for now.